So we need to confirm that the integral test can be applied to this series, and then we need to use the integral test to determine the convergence or divergence of the given series. This series can be represented as, so this series equals the sum of ln of n divided by n, where n goes from 2 to infinity. Before getting into the integral test, we must assure two things. For the integral test to be applied to some series, we must have a n be greater than 0 for the given interval, and f of n must be decreasing on the same integral. So here we have that ln of n is always greater than 0. So that means for positive n. So that means that this condition is satisfied. And we also have that n is greater than 0, so that means that in our case the nth term is always greater than 0 on the same interval. We also know that ln of n grows slower than n. So that means that ln of n over n is decreasing. Since both of these conditions are satisfied, that means that the integral test can be applied. So if the integral converges to a real finite value, then the series converges. If the integral diverges, then the series diverges. The integral corresponding to our series is the integral of ln of x over x dx, which goes from 2 to infinity. And we need to take the limit of the integral from 2 to infinity of ln of x over x dx, where b approaches infinity. Sorry, from 2 to b, where b approaches infinity. Then we will make a substitution here. We let u be equal ln of x, and then du equals 1 over x dx. So we get that our expression equals the limit of the integral u du from ln of 2 to ln of b, where b approaches infinity. Then this equals the limit of 1 over 2 u squared from ln of 2 to ln of b, where b approaches infinity. Then this equals the limit of 1 over 2 ln squared of b, where b approaches infinity, minus 1 over 2 ln squared of 2. Since b approaches infinity, we know that ln of b approaches infinity as well. So basically this equals infinity. So that means that the integral diverges and our series diverges as well. So the series is divergent.